Good morning. This is Terrence Barkin from the Graphene Council. I'm the Executive Director. We are the largest organization in the world for graphene professionals, including academics, commercial people, government regulatory agencies, researchers, anybody who's interested in working with graphene material. The Graphene Council is a formal member of the ISO, ANSI, IEC standards development bodies. We produce a weekly graphene intelligence briefing for our members. And part of what we're doing today is bringing additional information to you. And we're very happy to bring a program called Developing and Maintaining Safety Programs for Your Nanotechnology Business in collaboration with and in partnership with NIOSH. So if you'd like more information about the Graphene Council and access to the information that we provide, there's some links here. We're very happy to provide this session, which is being recorded, so you'll receive a copy of the recording and a copy of all the presentation slides. At this point, I'd like to hand this over to Seth McCormick and Matthew Dahm from NIOSH, who will be doing today's presentation. If you have questions, you can please use the Q&A dialog box, and I'll ask the gentlemen these questions at the end of the session. And we'll just turn it over from there. So Matthew and Seth, it's all yours. Thank you for participating today.
All right, hello everyone. My name is Matt Dahm, and beside me here I have Seth McCormick. We are both industrial hygienists at the National Institute for Occupational Safety and Health in the United States. My past experience for the last decade, I've been working at NIOSH. During that time, I primarily focused on developing air sampling methods for carbonaceous nanomaterials, mostly for carbon nanotubes and nanofibers. During that time period, I probably visited about 35 or 40 different companies, either producing or using carbon nanotubes in various industries across the United States. And we're actually switching to a new study, which is part of the reason why we're giving this presentation, to develop air sampling methods for graphene and to assess what exposures look like across the United States, because currently there's no information available. Seth, here, you want to talk about a little bit about your background?
Yeah, I worked at an OSHA training facility developing and delivering training courses. And after that, I went to the United Steelworkers for a while to work in their health and safety program.
So the title of our presentation is Developing and Maintaining Safety Programs for Your Nanotechnology Business. So a little caveat, there is no cookie cutter safety program for nanotechnology businesses in general. This presentation is aimed at kind of giving you the building blocks on how to start your safety program, because what we've noticed from going to various nanotechnology businesses is, generally there are small to medium-sized businesses. They have a very strong business or technical background. Obviously you're developing a new technology. And kind of there's a black hole around developing a safety program. It's almost, can be daunting to start your own program. You don't really know where to start. So hopefully this presentation will kind of give you those building blocks on how to develop your safety program and maintain it. So first off, I just want to say a little bit about what the National Institute for Occupational Safety and Health is. We are a research institute. We develop new knowledge in the field of occupational safety and health, and we transfer that knowledge into the workplace. We are not a regulatory or enforcement body in the U.S. government. Most people get us confused with the Occupational Safety and Health Administration. That's OSHA. That is a regulatory body. The difference is, OSHA is housed in the Department of Labor. In the U.S. government, we are actually in the Department of Health and Human Services under the Centers for Disease Control and Prevention. And again, NIOSH is research and training only. We are not regulatory at all.
So this is an outline of what we're going to discuss today. It's essentially 10 easy things to get your program started, the building blocks that Matt discussed. So first, we want to set safety and health as a top priority, and then we'll discuss leading by example, implementing a reporting system, provide training, hazard identification and assessment, conduct inspections, implement hazard controls, address emergencies, seek input on workplace changes, and make improvements. So this is a graphic that kind of explain something that could be counterintuitive to people that are in the small and medium range businesses. The direct cost of implementing a safety and health program and maintaining it is actually makes sense monetarily. You actually have a bunch of indirect costs associated with not having the safety program, and that can include stoppage due to workplace investigations, training new replacement workers for injured workers, workers' comp costs, insurance costs, and loss or damage to material, machinery, or property. And currently, research indicates that the indirect costs of not having a safety program are 2.7 times the direct cost of developing, implementing, and maintaining a safety program. So no presentation's complete without a couple of cheesy graphics. So here's our first one. Essentially, this is pretty self-explanatory, but if you're new to the safety initiative, it could kind of slip between the cracks. So the point here is that management needs to follow the safety rules to show that safety is a top priority. That means if you're on the floor and certain personal protective equipment is required for a certain area, you need to show your employees that you support this initiative by following the safety policies that you've put in place. So this is actually an OSHA requirement, and right here I'll kind of insert a little footnote that any kind of regulations or OSHA citations that we mention throughout this webinar is specifically for facilities within America. So, you know, these are probably still considerations if we have anybody internationally viewing, but you would want to check your regulatory body before, you know, before actually implementing this. So OSHA requires the development of a simple procedure for workers to report injuries, illnesses, incidents, hazards, safety and health concerns. This also includes near misses. You know, if a worker almost got hurt doing something, it's worth reporting because, you know, it's better to prevent it than to wait for an issue to arise and then address it. So you want to communicate the procedure to your workers and include an option to report anonymously. And OSHA also requires that workers be encouraged to use this system without fear of retaliation from management. So training is a pretty good basic way to get everyone on board with your safety initiative. So you want to train workers not just on specifics, but also how to identify and control hazards. There's a hazard identification tool that we have included in the resources at the end. And we recommend you just letting your workers go through that. It's an interactive tool that kind of gets the safety discussion rolling. And then there's certain types of training that's required before certain activities and equipment operation, such as forklift operation. You have to be OSHA trained to run a forklift at a job site, and then you have to be refreshed every 2 years. And we recommend you just get on OSHA's website and check for specific training requirements and how they relate to you guys so we can ensure that your facility is in compliance.
So another important thing is to identify hazards and to assess them. So one way that you can kind of prioritize hazards is through risk or identifying the risk. So, you know, any company is gonna, you know, you're not only handling graphene, right? You're probably handling tens or even hundreds of different chemicals within your workplace. So how do you identify which chemicals need to be a priority or which processes need to be a priority that you need to investigate a little bit more? So this is just a simple way to kind of address that. So the equation is simply risk equals hazard times exposure. So hazard being, you know, what is the health consequence? What is the toxicity of the material that you're handling? Are there any physical hazards associated with it? You know, is it caustic? Is it flammable? Is it explosive? And then exposure is simply the, you know, the amount or the quantity of material you're being exposed to. How much are you actually handling? How much do you have on site? What's the likelihood of exposure actually occurring? What are the routes that can occur? You know, is inhalation the the route of concern, or is ingestion perhaps the route of concern? That all plays a factor in the total dose that a worker can be exposed to. So really, you can combine these two to kind of define what your risk is, and then you can prioritize which chemicals you need to pay more attention to within your facility. So an example that we saw actually at a carbon nanotube facility was, it was a relatively small company that was just kind of introducing carbon nanotubes into their products. And they were only handling about 5 grams of material a day, which is a very small quantity. And they were taking it from a dry powder and putting it into a liquid that went into a composite. So they were very focused on the safety protocol and how to handle it and how they were handling and the personal protective equipment that they were wearing. While on the other side of the building at the same time that they were doing this, they had a worker that was actually handling gallons of hydrofluoric acid inside of a chemical fume hood that probably wasn't adequate to control exposures. So, HF is much more hazardous. It's caustic, it can cause some severe burning of your lungs if you inhale it. Obviously, it can burn your skin, go straight to the bone if it gets on your skin. The person wasn't wearing the right type of personal protective equipment. So at the end of the day, we kind of told them, like, hey, we're really happy that you're paying attention to this, to assess this risk for carbon nanotubes. But we actually think you need to probably focus more of your time and energy on this process over here that's using the hydrofluoric acid, because that's more of the immediate risk right now. So this is just, again, a simple tool that you can use to identify risk and prioritize it within your business.
So now that Matt has described how to characterize and quantify risk to help you prioritize what you need to address first, it's important that we understand what safety is. The preventative safety approach is like I said, it's better to prevent than to address after the fact. So we all know that human and machine error are unavoidable, but our job is to make sure that things fail safely. And that means we find a way to minimize harm when error does occur. And error is going to occur. Nothing runs perfectly all the time. So we need to make sure that we evaluate our program based on the presence of defenses, not the absence of accidents. So to the right here, we have a prevention through design wheel. And essentially, it's just telling you that you need to take what Matt said about risk characterization and take a holistic view of every aspect of work from start to finish, and find ways that find ways that you can control safety to provide you with the means to fail safer. So the next step in this is to actually get to the floor and put what we've learned so far into action. So we want to assess and inspect the workplace for these risks and hazards. So, we can use checklists, we can watch workers just doing work, ensure equipment is running properly, and use industrial hygiene air sampling methods to assess, airborne chemicals or processes that cause you the most risk. OSHA has a small business handbook that helps identify and get you started with the inspection process, and engage your workers. These are the people that are experiencing risk throughout the day. If something gives them an adrenaline spike because they almost got hurt, or if it's a near miss, then it's worth asking and trying to get some information out of them about an activity, piece of equipment, or material that causes them concern. So here's how we control and improve safety at our facilities. This is called the hierarchy of controls. It's kind of a cornerstone of safety controls. You guys have probably seen this out, just in general research. But essentially, elimination is the most effective, and PPE is the least effective. Personal protective equipment is the least effective. Elimination and substitution aren't always possible, but I encourage you guys to take a look at it and consider this when designing new processes or expanding your operations. An example of elimination would be removing a slippery floor finish to prevent slips in your facility. And an example of substitution, as Matt mentioned earlier, a highly corrosive or caustic acid such as hydrogen fluoride maybe there's a way to change your process a little bit to use a less caustic acid to reduce the exposure to risk to your employees. So engineering controls are kind of the gold standard. They can almost always be applied. It's just important to really realize that one size doesn't fit all. You need to look at each process and address it individually. Don't say, well, you saw a picture in our presentation, so this is exactly what you need. You need to make sure that it fits each process. So the top right picture is an example of exhaust ventilation that prevents dust from reaching the worker's breathing zone. This is, again, prevention through design. This person may not need a respirator because an engineering control is being effectively used. Currently, NIOSH, again, not a regulatory agency, but this is a kind of a recommendation for two nanomaterials, and that's for ultrafine titanium dioxide and for CNTs and CNFs. Currently, there's nothing else, no other recommendations for nanomaterials. On the bottom right, you see an inflatable seal for nanopowder that can help during the boxing process. Again, this is preventing the dust from ever getting into the airstream. So, workers may not need to use PPE, personal protective equipment, or, other means to protect themselves if this is being effectively implemented. And then the sticky mats are kind of a thing we've actually seen at some facilities at exits, and it keeps you from tracking it through offices and keeps you from taking it home and potentially exposing your family. Another example of a simple engineering control is handrails. We take that for granted and think it's just something that's always there, but it makes it to where if someone slips from an elevated platform, it's a basic slip as opposed to potential hospitalization or death. So next we have administrative controls, and safety policies are good. It changes the way that people work. One example is lockout tagout, which essentially is only one person can have control of any piece of equipment at once. This makes sure that nobody starts machinery when someone is potentially in a hazardous location. I actually read about a story for it was a tuna company in California a few years ago, and they failed to implement lockout tagout. A maintenance worker was actually killed in an industrial oven because nobody knew he was working on the inside of the oven, and a shift worker came and started the oven up, and the man was cooked to death, essentially. The facility ended up having to settle criminal charges for $6 million, and the safety professionals actually almost faced jail time for negligence. So lockout tagout, had it been implemented, the shift worker could have never started it because only one person would have had control over the equipment. Another thing is written safety rules. They should be posted in areas of high visibility. And it's also a good idea to post safety rules for equipment on that equipment. This also helps keep safety at the top of the mind for the workers, and again, reiterate that safety is a primary concern. Signs can be useful too throughout the facility. This can direct traffic of forklifts or other equipment, foot traffic even, warn of hazardous areas, and notify employees of specific PPE requirements for each place. And then safety training we touched on earlier, but again, it's just it's a good idea to have frequent safety training. And if you go in and you see someone reporting a certain amount of injuries from a certain type of equipment or certain near misses, these are areas where you may want to, add more training. And then the last, I had a professor in school that always said this was me admitting that I'd failed my job as a safety professional. He called this a Band-Aid. We've failed at every other level to protect our employees, so now we have to give them gloves, footwear, eye protection, respiratory protection, etc. Just like every other safety control we've discussed here, the takeaway from this is to make sure that you're using the correct equipment for the task. Address everything individually and make sure that the correct controls are being used. So this is a NIOSH resource, and I think it's pretty interesting, and it can be used as a template for other hazards and risks at your facility. So we'll just go through the dry powder for now, because it's the highest potential for exposure in most facilities. So here we see the work activity, and you see that there's a higher potential for exposure for dumping bags, powder, bagging, or sieving products. So first we look at an engineering control, and we see that we could use chemical fume hood, glove box, nanomaterial handling enclosure, HEPA filter, local exhaust ventilation, or just ventilated bagging or dumping stations. And then we have administrative controls such as establishing a chemical hygiene plan, performing routine housekeeping, and training workers, etc. And then personal protective equipment, again, when you just couldn't figure anything else out to protect your workers, you have chemical resistant gloves, lab coats, and safety glasses, goggles, or face shields.
So another thing you kind of need to think about is how to address emergencies. And these can be emergencies related to the processes within your business. So as Seth said, every process will fail at some point. So you just have to identify, the chemical processes within your plant that can fail. And then how are you going to, respond to that? How are you going to respond to that emergency? How are you going to respond if there's a spill or if there's an accident? You have to develop safety protocols for that. But not only does it need to be process dry, but there's other foreseeable emergency scenarios, which include medical emergencies, tornadoes, floods, earthquakes, fires. Where are you going to shelter in place, as a company, if there's a tornado or an earthquake? Or where is the meeting point when you evacuate the building in case there's a fire or there's a chemical leak? These are important things to have documented within your company. But you also have to communicate this regularly with your workers. We've been into businesses where they have great safety plans. It's written down very well. It's easy to follow, but they don't ever regularly train their workers. So just because it's written down doesn't mean everyone knows how to follow it. So you have to continually train your workers for them to understand that. So another thing that you want to be prepared for is, as we mentioned, how to handle a spill, either be a liquid or a solid, a dry powder. So have a plan for these spills. They sell nanomaterial spill kits. To be honest, it's not much different than just a regular spill kit that you can buy on the market. They're not very expensive. Typically, they'll include some sort of barricade, maybe personal protective equipment like gloves, maybe a respirator. It'll also have absorbent materials, disposable wipes, sealable plastic bags to dispose of the materials. We also suggest having maybe sticky mats on hand because that way, if it was on the floor and some people step through it, they're not going to be tracking it all over, the floor everywhere else. HEPA filter vacuums are obviously important. Sometimes what we recommend is using more of a pharmaceutical grade vacuum cleaner. They're designed for easy change filters, so the filter is actually enclosed within the vacuum cleaner. So when it needs to be changed out, you simply just put a cap on it, and then it's totally enclosed. You can throw it away or dispose of it however you need to dispose it. We've seen a lot of places using shop vacs where they fit a HEPA vac or a HEPA filter onto it. And that's not really ideal because shop vacs aren't sealed completely. So essentially what they're doing is when they're vacuuming out material, maybe they're collecting like 75% of it, of whatever's on the ground, but then that other 25 is just being resuspended. We've also seen instances where businesses use compressed air to clean surfaces. So that's basically just blowing material and redispersing it throughout the facility. So that's obviously not ideal. You want to make sure that you clean it, you contain it as fast as you can. Another thing to be aware of are dust explosions. If you're handling large quantities of dry powders, generally we haven't seen this being a huge issue in nanomaterial businesses because unlike other businesses, maybe like a bakery where they're handling large quantities of flour or a sugar refinery where they're handling large amounts of powdered sugar, generally carbonaceous nanomaterials are expensive. You don't want to have an inch thick, mat of carbon nanotubes or graphene on your ground, on the floor, that can then be suspended and cause a dust explosion. That's typically not what we see. More typically what we see is, just over time, dust will settle on various surfaces. You might have equipment that might start to, have a black sprinkle on top of it. So what we recommend is, just continually have a housekeeping protocol set up, maybe monthly, go through and wet wipe surfaces, make sure that there's no accumulating dust. OSHA has a nice resource on preventing and mitigating the effects of fire and explosions. It basically comes down to something that they call the dust explosion pentagon. You have to have an ignition source. The dust has to be dispersed. It has to be some sort of confinement, either a process, an enclosure, or it could even be, if there's enough material in your business, it could be your entire facility as a whole, so confined space. But then there has to be sufficient oxygen and fuel as well. So if you could maintain one of these and, maybe prevent dust from accumulating in the first place, then it's not that big of an issue.
So cue the second cheesy graphic of the presentation. So again, I've mentioned this earlier. Your work, the people doing the work are really the best resource. They know what scares them. They know where the risks are. But in addition to seeking their input to find and identify hazards, you should also seek their input before you go and make changes to the workplace, work organization, equipment, or materials. Because it's possible that you'd be committing or creating a new problem trying to fix one. So it also increases the level of investment your workers have in the safety program. And here it's, it's easy once you set up and implement a safety program to become complacent. Oh, we made it safe, so it's good. The point here is you watch how operations occur, you watch how work happens, and you find ways to continuously improve the amount of defenses you have against failures, and make sure that they can continuously improve how safe they fail. Here, the next couple slides are some resources. They really get into the weeds with it and get very specific. Some of this may or may not apply to everyone that's watching, so we didn't want to go into detail, but we thought that both of these slides are worth your time to just go through and scan them through and see if you think you could get some information out of them, some utility. So there's some really good resources that NIOSH has put out on this subject. And here's some more resources if you want to, again, continuing. This is just the references that we used to put this webinar together. Feel free to check it out for additional information as well.
Yeah, and I just kind of want to summarize one quick thing. So, there is no right way to develop your safety program. Each safety program is going to be unique to your facility. But one thing that I think I've seen in common with a lot of companies that do a good job of this is they really include their workers. It's a top-down process. Management has to support it, but it has to include the workers as well. And what we typically see with maybe medium to small businesses that are just starting a safety program is they create maybe like a health and safety work group or something like that includes management, but it also includes workers on the floor that are handling the materials. They might meet monthly or biweekly or even weekly to discuss safety issues, and that really kind of gets the ball rolling. And because the people who are actually handling the materials on a day-to-day basis, they'll be able to tell you, what they're concerned about, what things that you should focus on, things like that. So that's really kind of I think a good way to jumpstart your safety program. So that's the last slide we had on that. I wanted to throw a quick pitch about this upcoming exposure study on graphene that I mentioned during the first slide. So essentially what we're doing is we're hoping to identify companies within the United States that are either producing graphene or using it in some downstream manufacturing process. And we would like to work with them and participate in a study that is aimed at, developing air sampling methods to assess occupational exposures, and then kind of developing, what is an average exposure to graphene within the United States, because currently that information is unavailable. So the reason that this study is important is, again, it's important to have consensus sampling methods so that everyone in industry is, sampling the same way. It's comparable, the results are. The other thing is that this is kind of a jumping off point to develop occupational exposure limits. So those are essentially, there's lots of occupational exposure limits for various chemicals. There isn't currently one developed for graphene. So by understanding what actual exposures look like in the United States, we can kind of start that process of developing that. And that will provide information on, are your workers safe or are they not safe? Are they below the occupational exposure limit with no health effects are expected to occur, or are they above it where health effects may occur? So as far as participating go, individual workers, they'll simply wear this fishing vest that we have pictured here that has a few air sampling pumps in it. They'll be asked to wear it for their full work shift. And at the end of the work shift, we'll collect that from them and we'll ask them a few questions. Our direct interaction with the workers is less than 15 minutes per day, just, putting that vest on, asking them the questions at the end of the day and taking it off. The workers will receive an individual letter from us explaining what their exposures were and how that compares to other people's at their workplace, and then other workplaces that are doing similar work as them. Companies will benefit from participating in this study by they'll receive a pretty thorough industrial hygiene report, kind of going through all the exposure samples that we collected at their facility. We'll be able to provide recommendations based on processes or things that we saw or the exposure results to actually reduce exposures. And it's been very beneficial for the companies because they have used, in the United States, they have to report to the EPA for TSCA requirements. So there is a requirement for occupational exposure information. Generally, these companies have used this report to kind of suffice that requirement for their pre-manufacturing notices. So I think they've gotten a lot of benefit out of it. So that'll kind of be my plug for that. If anyone has any questions about the presentation or about participating in this new exposure study on graphene, here's my assess contact information. Please feel free to send us an email or give us a phone call at any time. So I think we can open it up now for questions.
That's great. Matthew, Seth, thank you both for that. I appreciate your time and effort in putting this together, and hopefully this is certainly going to be of help to our participants. We have folks from the academic community that are doing research. We have people who are new to manufacturing of nanomaterials, and we have very experienced chemical companies that are also new to graphene. So like I say, I hope this will be of help to them, and we certainly encourage our members to participate in your exposure study that is limited to companies and installations in the United States. But that's very important that we do get participation to that, because that's something all of us, the whole industry, will benefit from. If you have a question for either of the gentlemen on what you've seen, or particular to how you can improve your safety protocols, please use the chat box or the Q&A. We don't have any questions that have come through, so that's probably an indication that you guys were pretty thorough and provided information that was easily understood. We do have one question coming in, so we'll bear with us there just for a moment as that's getting posted. But I thought it was very helpful, and like I said, I think, sorry, there's a question. It's regarding the picture of the fume hoods. And while that one is being written out, let's go to the next question that's here. So what is the timeline for the study, and when do you plan to publish the results?
So we're actually just starting the study this year. It'll be a 3-year study. So the goal is to visit 4 to 5 different companies across the United States a year for a total of either 12 to 15 companies at the end of the 3-year study. So I would anticipate us publishing the results around 2021, 2022, since it'll be a 3-year study.
Okay, great. Thank you for that. We've had a few folks ask if there's going to be a copy of these presentation slides. You will not only get a copy of the presentation slides, but we will distribute a link to a recording. And this is free to attend. The Graphene Council has been happy to host this webinar, and really appreciate the participation of our NIOSH colleagues in presenting this. So that's freely available, and we'll have that published. Regarding the fume hood illustration that you had, there's a question about engineering control. So there was a flexible tube in the picture. Do you believe it is good practice for powder to use? I guess it's the corrugated or the ribbed hosing. Isn't it better to use a smooth surface? So I know that's rather specific for the fume hood. Any opinion on that?
I actually used to, I didn't mention this in my introduction, but I actually used to sell HVAC equipment, and this was included. It's generally, I think, kind of the approach. There's certain velocities that have to be maintained for this kind of source capture, this source capture ventilation. So I think in general, you're not that worried because the material is going to be so just moving so quickly, it's not going to have a chance to settle. With that being said, that does fall into the maintaining your safety program. You do need to periodically clean your equipment, no matter how you go with, if you go with corrugated or smooth, it's going to need to be cleaned anyway, either way, because there's seams in a lot of most of this duct. So it's actually like, so this is actually spiral duct, and it's got a continuous seam that's actually against the airflow the entire time. So you're going to have to clean your exhaust duct out at some point, regardless of how you approach it. But I do think that this is kind of industry standard, so that they can have flexibility.
Yeah, and typically what we see, I mean, obviously straight is better. The less corrugated, that's the less ridges that material can collect and stuff like that. So straight's better. But depending on your facility, are you R&D or are you straight manufacturing? Stuff like this, these elephant trunks give you a little bit more flexibility in, what you can do. If you're manufacturing, you can develop your HVAC system to be specific to what you're doing. But if you're constantly changing your processes, you want to have a little bit more flexibility in your engineering controls. And this, these elephant trunks can give you a little bit more flexibility. They're maybe not ideal, but it's definitely better than nothing. But yeah, straight ducting is going to be much better than corrugated, and the less, turns and bends that you have, the better it is.
And that's a good point that Matt mentioned. If you're more of a larger quantity process, you may go with an exhaust ventilation hood as opposed to something that moves with the worker, such as this. So that ties in. He hit the point again that one size doesn't fit all. You really need to address it based on process. And like he said, it looks like these guys are moving and from station to station, so maybe a hood wasn't feasible. But yes, a hood would allow you to stay straight with your ventilation and probably cover a bigger area as well.
Great. So we've got a few more questions to get through now. I think there was a slide that talked about the personal protection equipment, and in particular that there's no single mask that will cover every type of material. So the question is, are there any particular masks that can be useful when working with nanomaterials? And of course, for today's call and for our audience in particular, we're interested in graphene, which can be in the 1 nanometer by 5 micron dimensions or less, right?
Yeah, so NIOSH has done a good amount of research on this, and actually all NIOSH certified respirators are effective. So that's going down to N95 all up the way to a full face, P100 cartridge respirator. I generally try to stay away from the filtering face pieces. That's like your common N95, just because the fit isn't as good. I prefer either a half face elastomeric, which is what this individual is wearing here, the more rubbery respirators with P100 cartridges, and either that or a full face respirator, depending on your process and how much material you're handling. It's obviously going to be specific to your business. But it's actually counterintuitive. Actually, the smaller the material is, the more effective the respirator is at actually, protecting the worker. So that's kind of a counterintuitive thing that people don't think about.
Okay, thank you for that. So there's another question on the 2018 203 publication. How can somebody get a copy of that?
Which one is that?
Yeah, I'm sorry, can you repeat that?
Yeah, it's referenced as the 2018-203 publication. No.
Well, all these references, I'm not sure which one they're speaking to, but if you click the links, it should go straight to the PDF once you have the presentation. So all these will be available to everyone. And if for whatever reason the link's broken, if you go to the Nanotechnology Research Center on the NIOSH webpage, all these documents are posted here.
Okay.
And none of them, nobody should have to pay for access to any of these. These should be.
Yeah, it's all publicly available.
Yeah.
Excellent. Thank you. Another question is, are there any current exposure levels, inhalation levels, known in the literature for graphene? I think you mentioned that there weren't, but the question asks if there is anything known in the literature. Are you aware of any?
So there have been 2 exposure studies. I believe one was in Italy and one was in Korea. But I think it only involved one facility, and it wasn't really the way that we will be sampling here in the United States. So it's maybe not as applicable to people in the United States as it is at other places around the world. But there's been very limited information. And the reason that this is beneficial to provide what's a realistic exposure to graphene across the United States is because one of the things that we learn from dealing with carbon nanotubes is animal studies are going to be occurring. There haven't been many inhalation animal studies conducted on graphene at this point. But for carbon nanotubes, they started dosing animals at very unrealistic levels. And when I say unrealistic, I mean they were dosing them at higher levels than anyone who would be working for even 30 years in a carbon nanotube manufacturing place in the United States would ever be exposed to. And some of the health effects they were finding maybe weren't applicable to what the exposure levels actually are. So by doing a study like this, we can actually inform the toxicologists that are doing these animal studies what's a realistic dose level to dose these animals, and which is very beneficial.
Excellent. Thank you for that. Another health-related question is, has any work been done on the ability for graphene-based materials, and I assume that would be just graphene itself as well, to pass through the skin barrier and or the blood-brain barrier?
So, as I mentioned, there haven't been too many animal studies that I've seen on graphene that have come out recently. Graphene's, as far as I'm aware, and obviously you guys are the experts, but really it's only been in mainstream manufacturing for less than a decade. So it takes some time for these types of studies to get out. As far as other carbonaceous nanomaterials go, there has been some evidence that carbon nanotubes can cross the blood-brain barrier, but I haven't seen that evidence for graphene yet. And dermally, I don't think there's been much evidence at all, even for carbon nanotubes, that it can pass, intact skin, the intact dermal layer. If there are abrasions or there are cuts in the skin, yes, then it can get in. But if it's totally intact dermal layer, then no, there hasn't been any evidence that it can translocate that.
Excellent. And a related question is, if you have an opinion on this, do you think it's a good idea to compare graphene exposure to carbon black exposure?
I think it's too early to tell that fully yet. I think a lot of the animal inhalation studies that I've seen on graphene have shown that it's actually much more benign than carbon black or even carbon nanotubes, but it's still very early in the game. And the problem that we have with carbon nanotubes, which we're going to have a similar problem with graphene, is there's obviously different types of graphene. And it takes a while to establish the literature on the toxicity on all those different types of graphene. You can functionalize it with anything essentially. So it takes time for those studies to get out. So we're not going to have that answer, next year or the year after that. It might be another 5 years, 10 years until we start really having a more lucid picture of what that toxicity is, if there is any at all.
Great. And I think you might have answered this already. There was a question regarding carbon fiber dust, which I'm not sure if the carbon fiber, if that's really referring to, well, carbon fiber, I guess, in composites. So carbon fiber dust exposure, and is there any danger related to the electrical charge and conductivity? The fact that graphene is electrically conductive, does that pose any specific health-related threats?
So as far as health-related, I would say no, but what we tried to get at with the explosivity slide was that it can spontaneously ignite. You know, that it does carry a charge, it can be charged. So you just have to be careful. So like that slide that we were just discussing a second ago with the elephant trunks, the ventilation, you know, we've seen places where maybe a good amount of material collects in those ducts. And then, you know, just by simple, you know, essentially like microscopic friction of the materials over time can create a charge and a spark, and then that can catch on fire. So you just, like as Seth mentioned, you have to do periodic maintenance, make sure your ducts are clean, you know, make sure make sure everything's grounded. You know, just do periodic housekeeping, you know, make sure everything's clean, you know, maybe once a month, go throughout your facility and just wet wipe surfaces, stuff like that, so dust doesn't accumulate.
Okay. We did have a question about processes on, you know, what's the best way to actually clean some of this stuff. So I don't know if you have another reference or source for that kind of cleaning techniques.
Yeah, I don't know if we included it in this resources section, but there's, you know, NIOSH on the Nanotechnology Research Center, NIOSH website. We do have, you know, kind of like a lab safety protocol document that kind of goes into how do you handle, how can you clean certain things. But again, it's hard to answer that question because that could be very specific to your business or how you're handling the materials. So, but there is general information that NIOSH has put out. And this is really, again, a benefit, you know, to the study that we're trying to do. A lot of these observations that are in these NIOSH documents are coming from, you know, us, you know, the boots on the ground, us actually going into workplaces and seeing how the material is being handled, you know, issues that, you know, are commonly occurring within various companies. We can then put those out in documents that then, you know, can benefit the entire industry.
Excellent. And like I say, we really encourage people to contact you if they'd like to participate in that study. I think there's some huge benefits. We do have a question about the monitoring program regarding the monitoring devices. If they're able to catch nano powder, which I assume they are because that's what you're looking for. And then what's the analytical method you're going to then use to determine if it's, you know, parts per million or by weight, or how, you know, how are you actually calculating or counting the exposure levels?
So as we mentioned, right now, you know, we're still trying to develop those methods. There's nothing set in stone, but what we've done for carbon nanotubes is actually mass. So we're looking at micrograms per cubic meter in air. That's generally how we collect it. Now we look at specific elemental carbon mass. So there's a method we use called NIOSH method 5040, which gets the specific mass of elemental carbon, which, you know, there are some background interferences. You know, obviously diesel exhaust could be one, different types of air pollution. But for the most part, you know, we're able to quantify the graphene exposure through that. We also use different types of microscopy to verify that, you know, graphene is actually there. And we have different ways to quantify it through that method too.
Excellent. There's a question regarding HEPA filters. If HEPA filters on every exhaust line are suitable to catch graphene and nanoparticles.
Yeah, I mean, HEPA filters, I mean, depending on the type of HEPA filter you use, you know, it's 99.9, you know, 99% efficient. So yes, it is effective in capturing, you know, micron or even nanomaterial sized particles.
Okay. And you did mention the lack of studies. There is another question here. Are there any known lung complications from inhaling graphene nanomaterials to date? Just to
No, there have been no human studies. There's been no case studies showing effects of graphene exposure on humans. Again, we're very early in this game, right? You know, there's still controversy on, you know, asbestos cause mesothelioma? That's hundreds of years of evidence of that. So again, for graphene, we're 10 years in, so this is a very long road that we're approaching.
So we're still getting more questions, and which is great. Another question is there any established protocol for the disposal of carbon nanotubes or graphene waste?
So that's going to be, dependent on your country. I wouldn't say there is any hard and fast regulations in the U.S. on how to dispose of it. Most people dispose of it as hazardous waste, so it's either incinerated or it goes to a hazardous waste landfill. In most cases, it depends on how you're handling it too. If it's a dry powder, yeah, either incineration or hazardous waste landfill. If it's a liquid, a lot of companies will try to filter out any material left in the liquid, and then that will go as a dry powder to a hazardous waste landfill, and then the liquid can be recycled based on whatever the local regulation is.
Great. I know you've worked on some other materials, so have there been other 2D materials that you're aware of that have been studied regarding lung penetration or exposure?
No, I think the most, as I mentioned again and again, there's not a lot of evidence out there right now for any two-dimensional nanomaterial. Graphene's obviously the most well-studied and popular, and even in that, there's not a lot of information. So for other two-dimensional nanomaterials, there's hardly anything available out there right now.
Great. Well, gentlemen, I want to say thank you once again for your time in putting this together, and also for answering all the questions. We will send out a copy to all of our participants, and of course it has your contact information. So if anybody would like more information, please feel free to reach out to Seth or Matthew about this. And of course, if you have the opportunity and it's relevant to you, if you're handling graphene in your facility, either as an end user or as a manufacturer of this, or increasingly we have people who are in the compounding business who are using graphene as additives. If you have graphene in your facility in any way, shape, or form, please reach out to these gentlemen to participate in the exposure study. That will be beneficial to everybody. So thank you again, really appreciate it. And with that, we are going to close out our webinar today. Thank you again. Any last comments you guys want to make?
No, yeah, thank you for giving us this opportunity.
All right.
That question? Yeah.
Oh, we're good. We're good. Thanks, guys. Thank you, everyone. Have a great rest of your week.